When you really look out at the universe, it's essentially a massive locked room crime scene. We are basically here to investigate the greatest missing persons case in the history of, well, everything. We've got billions of years of history, billions of potential homes, and yet nobody is home. Or at least, nobody is answering the door. So let's put on our detective hats and see if we can figure out why. All right, let's actually rewind to a summer day back in 1950. Picture this. We're at a lunch at the Los Alamos National Laboratory. Nobel Prize-winning physicist Enrico Fermi is just sitting there with his colleagues, casually chatting about flying saucers and interstellar travel. And suddenly, seemingly out of nowhere, Fermi blurts out this incredibly simple yet completely chilling question. But where is everybody? And the wild thing is, everyone at that table instantly knew exactly what he meant. To really feel the crushing weight of that question, you just have to wrap your head around one number, 70 sextillion. That is 70 followed by 21 zeros, and it's the estimated number of stars in our observable universe. I mean, just in our own Milky Way galaxy alone, there are billions of stars similar to our sun, and many of them are billions of years older than ours. Logically, if even a tiny fractional percentage of those have Earth-like planets, the universe should literally be teeming with intelligent life and sprawling interstellar empires. Which brings us right to the core of this whole mystery, the Fermi paradox. It's this profound, honestly kind of maddening tension between the mind-boggling scale of the cosmos, which math tells us means we absolutely shouldn't be alone, and the deafening absolute silence we actually observe. After 13.8 billion years of cosmic history, we haven't found a single probe, not a single stray radio broadcast, or a single galactic megastructure. Just silence. Section 1, the math behind the silence. So, to crack this case, our best investigative roadmap is the Drake equation. Formulated by Frank Drake back in 1961, it's designed to calculate the exact probability of finding a technologically advanced civilization in our galaxy right now. It basically multiplies a bunch of factors together. It goes from the rate of star formation to the fraction of stars with planets to where life actually appears, where it gets intelligent, where they build broadcast tech, all the way down to how long a civilization survives before, well, going completely silent. But here's the catch, right? We don't actually know the real values for those later variables. Depending on how optimistic our cosmic detectives want to be with those unknowns, the math suggests we could have anywhere from 100 million chatting cosmic neighbors in the Milky Way to absolutely zero. We could be surrounded by millions of civilizations, or we could be entirely alone in the observable universe. Section 2. Searching for cosmic clues. Now, humanity's investigation hasn't just been sitting idle. It's escalated incredibly fast over the centuries. Way back in 1686, Bernard Le Bouvier de Fontenelle was already looking up and questioning an empty moon. By 1933, Russian rocket scientist Konstantin Tsiolkovsky formulated a really early version of the paradox. Then we hit Fermi's famous lunch, the Drake equation, and today we have intense, modern empirical searches for extraterrestrial intelligence. The SETI Institute, we are actively, constantly listening. But we hit a massive hurdle right out of the gate. It's often called the algae versus alumni problem. See, our remote sensing technology might eventually detect the chemical signatures of simple life, like algae or bacteria, on a distant exoplanet. But detecting a biosphere absolutely does not prove that the life is intelligent or capable of building a radio telescope or launching a spaceship. I mean, think about it. Dinosaurs lived on Earth for millions of years, and they were pretty impressive, but they never quite figured out how to build a rocket, right? Because of that, our search is entirely reliant on finding what we call technosignatures. We are actively scanning the cosmos for non-natural radio emissions, maybe the glow of artificial lighting on exoplanets, self-replicating von Neumann probes, or even Dyson spheres, which are these massive astroengineering projects that would surround a whole star and alter its light spectrum. And yet, despite decades of detailed observation using our most powerful telescopes, our suspect count remains at exactly 0. Section 3. Where is everybody hiding? So we can broadly toss the theories behind this mass disappearance into a few fascinating and honestly pretty terrifying buckets. They might be sociological, meaning they exist but just choose to hide or isolate. They could be evolutionary, meaning intelligence naturally ends up destroying itself. They could be economic, meaning crossing the galaxy is simply way too expensive. Or it could all just come down to rarity. We're simply alone. One absolutely crucial piece of this puzzle is the concept of the Great Filter. Introduced by Robin Hanson, this theory suggests that an almost impossible evolutionary leap, basically a massive bottleneck, exists somewhere in the steps between inanimate matter and a spacefaring civilization. And the terrifying question for us is that filter behind us? Like, did we already survive the hardest part when complex cells were created? Or is the filter ahead of us, meaning humanity is currently speeding toward an inevitable brick wall where almost every intelligent species goes extinct? Or, maybe it's not quite that grim. What if we just aren't late to the cosmic party at all? What if we're actually the very first ones to arrive? This is the firstborn hypothesis. Astrophysicists like Avi Loeb suggest that the universe has only relatively recently cooled and settled into a state where complex life is even possible. We're early. The universe might be absolutely teeming with life trillions of years from now, but right now, we happen to be the pioneers. But then we have a much darker evolutionary theory. A 2018 study by astrophysicist Adam Frank modeled civilization trajectories using extinct Earth societies like Easter Island as a baseline. And the models show that energy-intensive civilizations might generically trigger devastating climate change. If they don't transition to sustainable energy quickly enough, they undergo a rapid population die-off or a total collapse. It's just the laws of physics. Building a high-tech civilization leaves a massive planetary footprint, which could literally be a universal great filter. Now, when we look at the sociological suspects, things get incredibly sci-fi very quickly. Could it be the zoo hypothesis? That's the idea that advanced aliens are out there treating Earth like a protected cosmic wildlife reserve. Or, far more terrifyingly, is it the dark forest hypothesis? Popularized by author Liu Cixin, this is the idea that civilizations are deliberately silent and completely paranoid, just hiding in the dark, because the very first one to make a sound gets wiped out by an interstellar superpredator. Then there's what we call the economic alibi. Think about the sheer, mind-boggling amount of energy it takes to physically send ships across light years of space. It's astronomically expensive. Some calculations suggest it is millions or even quadrillions of times cheaper to just transmit information via radio or lasers. So perhaps advanced alien civilizations realize physical colonization is a massive waste of resources, and instead, they just beam their digitized minds into incredibly complex virtual realities. Why brave the cold, dead vacuum of space when you have the ultimate VR headset right at home? Which brings us to Section 4, Our Place in the Dark. Let's bring this all back home with a recent concept known as the grabby aliens model. It suggests that if loud, aggressively expanding civilizations existed in the universe, their spheres of influence would expand at near the speed of light. They would alter entire galaxies, making them practically impossible to miss. Because we look up and see an untouched, natural universe, it heavily implies these grabby civilizations are exceedingly rare, which, again, really reinforces the idea that humanity exists incredibly early in the timeline of the cosmos. And this perfectly sets up a genuinely chilling warning from sci-fi author Greg Bear. He wrote, "We've been sitting in our tree, chirping like foolish birds for over a century now. The galactic skies are full of hawks." It highlights a massive ongoing debate in the scientific community today. Should we be actively broadcasting messages into space to say hello? Or is that a dangerously naive mistake in an unknown, potentially hostile universe where everyone else has the good sense to just keep quiet? So as we wrap up, our cosmic crime scene is still wide open. The Fermi paradox forces us to confront our ultimate place in reality. Are we the absolute pinnacle of cosmic evolution, the universe's one and only hope for consciousness and intelligence? Or are we simply a fragile, naive spark sitting blindly in a dark, dangerous forest, entirely unaware of what is watching us from the shadows? It's a question that defines our past, and it will absolutely dictate our future. Thanks for tuning in and keep looking up.